to day two of this session workshop on VMware virtualization. I appreciate your patience and I'm really sorry about the delay. I had to travel to my friend's home in order to do this training because the place where I'm living, the internet is very bad. So I got stuck in the traffic. All right. So today's plan is first we'll do a recap. Let's see what we have done yesterday. And after that, I'm going to take you further to discuss about how a VMware server is set up, what are the storage requirements, what are the networking requirements, and how do we set up, and so on. So we're just going to go in the right direction, of course, right? Step by step. So first we discussed about what is virtualization. Now the next step is how do you set it up and what are the requirements and so on. And tomorrow we'll see what are the features within that and how cloud is actually being set up with the help of virtualization, right? So in the recap, yesterday we started with talking about the centralized management system, right? I explained you how important it is to have a centralized management system. I gave you the examples of ATM machines. If your ATM machines are not synchronized across, the banks would not be able to track your withdrawals or the right deposits from the machines. Likewise, we also talked about the data centers, how data can be centrally stored, what's the importance of storing data centrally, right? We talked about different types of applications which are set up, like database systems, email systems. We talked about security systems, antivirus systems, um, right? And so on. I'm sure you guys are able to listen to me fine, right? Can someone message me if you're able to hear me fine? Okay, thank you. All right, because someone just messaged me that he can't hear me. That's why. Okay. So that's important that we need to have our data centralized and we can do that by maintaining a data center, right? Then we talked about the history of virtualization yesterday, right? Why virtualization came into existence. Now we talked about the problems that we have with a physical machine, right? Physical machine, the first thing is our resources are wasted because if I buy a machine with certain amount of resources, if I'm not utilizing all the resources of that machine, they all are going to be in vain. I will not be able to use them, right? So resource sharing is not possible in physical machines. Um, Also, we talked about the kernel, right, which talks to hardware with only one hardware at a time, which means you cannot run multiple operating systems on the same hardware. That was another problem. Managing physical machines obviously is difficult because imagine you're buying like 1,000 physical machines and you need a huge building space for that. So there is a lot of cost involved in that. And obviously, if you're connecting your network switches and routers, you would obviously require a lot of network devices. So managing physical machines is costly and also very difficult, right? Migration of physical machines is complicated because if I'm moving a physical machine from one location to another location, I need a downtime and then I need to shut down that machine, pack that machine physically, and then carry that machine to the other location and then place it. So it's a big drama, right? So these were some of the problems that we discussed with the physical environment. Then we talked about virtual environment, right? I explained you how a hypervisor really is useful. A hypervisor basically is something which allows multiple VMs to run on the same hardware because the hypervisor is going to act as a mediator between your hardware and your virtual machines. So all the requests from the VMs would be taken by the hypervisor. It pretends itself as a hardware to the VM. So every VM thinks that the hypervisor is the hardware, and that's the only hardware running on that machine. And that's how hypervisor helps us to run multiple machines on the same hardware, right? Today we are going to see how do you set up this hypervisor, what are the requirements to set it up in real world, right? Not in terms of theory. I'm going to be talking about how it really is set up in an organization, right? In a real data center. Let's have a look at it. Let's go to our favorite whiteboard now. And so I'm going to be talking about, one second, right? So this is the agenda for today. Just one second, let's see. This thing. Oh, one second. That's good. Mm. Is it? Okay, we are here. So let's all together, we are going to build a hypervisor, or right, a ESXi. So let's say we all went to the market and we bought this physical machine. This is the hardware. And we have got our customer who said, I want to set up a couple of VMs, um, right, on this hypervisor. So let's say our requirement is we need some 6 odd VMs, right, on the physical box. 6 VMs is our requirement. So we have already learned about the sizing yesterday. So the total resource required for 6 VMs, let's say if that is 60 GB of RAM, and CPU could be second. So it should be like 15 cores of CPU. Okay. Okay. And say hard disk, they might have said like 1 TB of hard disk for this. Now we are going to buy the hardware. So 4:1, if I'm buying testing machines, I'm going to buy only half, not even half, 25% of it. 15 GB of RAM, I'm going to buy, right? And when it comes to CPU, I am going to buy, again, it's going to be 4:1. So it should be like, I'm just going to buy 4 cores of CPU, right? Hard disk also, we can buy 4:1 in the beginning, but later on we might require it. So generally we don't do for local hard disk. I'll talk about hard disk in some time. Let's leave it. We'll talk about when we're discussing storage. So we purchase the hardware. All right. Now we are going to set it up. How do I set it up? The first step that I need is I need to install ESXi on this physical machine. Now, installing ESXi is pretty straightforward. It's just like you're installing an operating system on a brand new hardware, right? So after you install your ESXi, this machine becomes an ESXi server. That's what we call it as. We call it as a host. Now, once it is, obviously when you're installing it, right? If you're installing Windows, what do you do with your hard disk? So who can tell me if I'm installing Windows, what do we do with the hard disk? You make partitions, right? You format it and you make partitions. Very good. In VMware also, you have to do that. You have to format it, right? In Windows, what type of file system do we have? Can you guys tell me? So Windows has NTFS, right? It also has REFS, and the older one is FAT32, right? FAT32. But in VMware, we have a different file system, right? What is a VMware file system? Who can tell me? Okay, very good. Many guys are answering. VMware has VMFS, NFS. These are the two file systems we have, right? All right, just one second. This guy. So VMware has got two types of file systems, NTFS, sorry, VMFS and NFS. We also have vSAN, but we don't call it as a file system though. But yes, there is something called vSAN also. So remember, point to be noted, we have two types of file systems, VMFS and NFS in VMware. It is just like how you do it in Windows, NTFS or REFS or something, and they have got their own benefits, right? All right, so when I'm installing ESXi, whatever hard disk I have, right, I am going to format my hard disk mostly with VMFS, and I am going to, after you format the file system, you create partitions, right? You guys said that on the chat. What partitions do we have in Windows? When you create partitions, what do you name it as? Yeah, you basically name them as C drive, D drive. We call them as drives, right? A partition in Windows is called as drive. A partition in VMware is called as data store, right? In Windows, we call it as drive. So both are same, right? In VMware, we call it as data store. Obviously, you need something to store your data. So we call it as a data store. Put it here. Let's take a red color. So this is my data store. Now it's up to you how many data stores you want to create. So if I've got like 500 GB or 1 TB of data hard disk space, I can create 10 data stores, like 100 GB each, like how you can do in Windows, right? Go for C drive, D drive, E drive, and so on and so forth. You can create smaller partitions. In VMware also, you can do that. You can create multiple data stores. The file system can be a VMFS or NFS file system. So initial formatting is done and partitions are created and your ESXi hypervisor is installed. So your host is ready now. But on a Windows machine, as soon as you install your operating system, you don't leave that machine as it is, right? You work on your actual requirements, right? Um, Now there's a question on the chat. What is a requirement to prerequisite to install ESXi? He's asking, do we need Windows or something? The answer is no. For ESXi, all you need is a blank hardware. We don't need to install anything on that brand new hardware. If there is an existing hardware that you want to use, all you have to do is just clean out the partitions, right? Or during the ESXi installation, you can just go ahead and it will delete those partitions. And then it's going to create a new one. You might get confused a bit. There is also a VMware Workstation Edition that can be deployed on a Windows machine, and even there is a Fusion available which can be deployed on Mac and so on. That is basically for home users. We are not even talking about that. We are talking about the data center solutions, right? So workstations which will be deployed on one Windows machines, just that is for someone who's just practicing something, that's not at all ESXi. That is something else. Okay, so ESXi is the server. We deploy data stores on that. The data stores are configured. The next step is to create virtual machines on this, right? So what I'm going to do, I'm going to create a VM. Take a different color, virtual machine. Now, when I create a VM, obviously I need to log into this host. Now, in VMware, the physical box that we have on which we have installed ESXi, if you log into that box, all you get to see is you get to see a command prompt, like more like a DOS command. Because this is a Linux based hypervisor, right? So you don't get to see any GUI on the machine that you log in. So how do I get the graphical user interface for this ESXi? For that, you would have to use your Windows machine. You can use your laptop. On this machine, you have to install vSphere client. Right? We have vSphere HTML client, we have web client, and so on. So there is some client, okay? From this machine, you need to access this. So how do you access? You can just use the IP address of this machine, or you can use the host name, right? And you just need to log in from the browser. When you log in, you get to see the GUI, right? Let me show you in the lab how it looks like. Here we go. So we have our lab in front of us. I am going to, this is a vSphere client, okay? It's taking me to vCenter. Hold on. So from the browser, all you can do is put the IP address of your hypervisor, something like this. This is our ESXi host, and it will ask you for the username and password. Now, this username that I'm putting here, during the installation of our ESXi, we had to set up this password, right? Just like how your Windows Server password you set up the same way. Okay. So in our case, we've already deployed the ESXi, and I'm logging in. As soon as I log in, one second. This is painful. Sorry, there are different versions. I need to see what passwords we have set up for this. Okay, thank God. Okay, as soon as I'm logged in, this is how I'm going to see. I am going to see a GUI, and it tells me this is my name, host name, which I've given during the installation. This is the version. Um, CPU, this is what it's got 15 giga, 0.2 gigahertz of speed. Memory, we have got total 12 GB RAM on this host, right? And it's used like 8.16. This is the storage, 249 GB storage on this machine. So this is how you get. Now we'll create a virtual machine on this. Let's see how to do that. We've already created few because this is an existing lab, of course. All you have to do is just say create register new VM. It tells you create a new virtual machine, and I can just give a name to this machine. Now, this name is not the operating system name that you install, right? This is just the name that you can see on the display here. Let's say demo, okay? Then I'm going to select the host compatibility. What type of operating system we are planning to install? Let's say I'm going to go with Windows, right? What is the version of Windows we're planning for? Maybe, let's say, Windows 2016, right? And then we go next. Now it's asking me, where do I want to store this virtual? Obviously, I need to select the partition, right? When you're installing um, something, let's say you're installing MS Office on your laptop, it will ask you for the drive that you have to select to install. Where do you have to install? This is exactly what it is asking for us. Where do we want to install this, create this virtual machine? So I'm just selecting this ESXi local. Then I need to assign how much, this is a VM, right? How much of CPU, how much of memory, how much of hard disk I want to allocate. So from the physical machine, we are going to assign this. Now remember, whatever I specify here, it doesn't mean that it's just going to block everything and assign to this machine. It is, for example, let me take you back to the whiteboard. Let us say this is our new host, right? On this host, our RAM is some 100 GB, right? And our CPU is, let us say, some 25 cores, and your hard disk is some 1000 GB, okay? So if I'm creating a VM, I'm going to assign RAM to this. Say I'll say 10 GB RAM. I'm going to say CPU, let's say 5 cores. Hard disk, let's say I'm going to say 100 GB. When I'm configuring and assigning this, it doesn't mean that it's just going to immediately, eat away all the 10. No, it doesn't do that. It's just going to create that configuration and store it. When you install the operating system on this machine and when you power it on, then is when it will start asking for resources. This is more like you applied for the loan from the bank and the bank said your loan is approved, but the amount is not yet deposited to your bank account. It's just approval is come. So now it's whenever you need it, obviously they were going to deposit that. But as if now you don't need it, approval is there, but it's like you're going abroad, you got the visa. So getting visa doesn't mean that you've already flown abroad, right? Just give me a second, guys. I'm getting a call. Okay, sorry guys, just a second. Huh? So you got the visa, but you have not yet flown abroad, right? Getting visa doesn't mean that you've already traveled abroad. So you got that. It's up to you. Whenever you want, you can travel, right? So approval is there. So this configuration doesn't mean that all the resources are assigned and eaten away. All right, keep that in mind. Let's go back to the lab. Just a second, guys. All right, so what I'm doing here is I am assigning the resources. It doesn't mean that it's just allocating everything. Okay, so I have decided we'll go with 2 GB, 2 CPUs and 4096 of megabytes. No, no, hold on. We'll go with GBs. So we'll go with 4 GB RAM. Okay, 90 GB hard disk. We'll talk a little more about hard disk in some time. There is provisionings and so on. We'll talk about it later on. This is the configuration of my machine, and I'm just going to finish this. Now the new machine is here, demo. But remember, as soon as I've configured the VM, it doesn't mean that my virtual machine is ready, right? It is basically just the configuration is done. For example, I go and buy a physical machine, right? So when you buy a physical machine, right, let's think of it like you're buying an assembled machine. So you buy hardware, right? You buy a motherboard, you buy the RAM, you buy the hard disk, you buy the CPU sockets, right? And you assemble the physical machine. Now, assembling physical machine does not mean that you would power on and start using that machine. It's still the hardware, which is just assembled. The next step would be to install the operating system, right? You have to create the partitions, format if it is Windows NTFS or REFS, do all that, right? This is just like that. This is a brand new, think of it like a brand new physical machine, but there is no operating system on this. This is the configuration of it. Now, if I power on this machine, there's nothing going to come up, okay? Because if you power on a brand new machine without any operating system installed, this is what you get, right? So I'm getting the same thing here. So the next action is I have to install the operating system on this. How do I do it? It's pretty straightforward. On a physical machine, what do? You get a bootable DVD, you put that DVD and you restart the machine, it boots from that DVD, and then you install the operating system. We do the same thing here. But here, because it's a virtual machine, right? You cannot put a physical DVD here. You have to use an ISO file. That ISO file has to be, first of all, uploaded to your data store, right? So for example, I go to data store. This is my ESXi server data store. I can browse this data store. I can say upload, and from my laptop, right? This is my desktop now. If you put it on your laptop, you can just select that, whatever you want. You can just say open and just upload. That would be uploaded here, all right? And then once it is uploaded, that ISO file, you can start the installation. For example, there is a mini OS available. I don't know if it will work or not, but let's see. 1 second. So once this ISO is uploaded, all you have to do is go to your virtual machine. First of all, power this off and then edit. And you have to you obviously put that in your DVD, right? CD DVD. Then just use that data store ISO, browse it. I think there's some file. For example, this one. I'm not sure if it will work, but yeah. So I have selected this, just save it. Now you power on, it'll boot from that DVD. Hopefully it should, yeah. So you see the installation of this started now. This is a Linux, right? Mini OS is a Linux version. So now the installation started, and it's just gonna go on. Sorry, right? Okay, it's installing that Linux on this. Now, in real time, yeah, the ISO has to be whatever ISO, right? Windows or Linux or anything that you have, the ISOs are available from the website. You can download it, right? You download the ISO file and you need to upload that onto your data store, right? And once that is there on the data store, you can install the operating system, right? Uh, so it has to be, remember, installation will happen only after you upload the ISO so far. So far, is this clear, guys? Any doubts? I want you to message me or raise your hands if it is clear so far. I see only a few people raising hands. Okay, a lot of people messaging on the chat. I see. Okay, all right. I know sometimes it kind of gets a bit boring while we're discussing few topics which are not so enticing, but I would want you to hold your horses, right? Everything is not fun. Sometimes you have to bear patience, right? Um, all right, so let's go on. Okay, very good. This installation drama will stop here because we don't need to learn how to install an operating system. I will close this. We'll get back to our agenda now. Just give me a second. I have some more. Okay, so we have learned how to create a virtual machine. The VM is created, partitions are created, right? And you can run the VM now, right? Now, VMFS, NFS, that is clear. Partitions are clear. Let's just give me a second. All right. Now, let's look at how this is actually set up in the real time. Okay, let's go to that. See, in real time, we don't use the local hard disk. The hard disk that comes with the hardware, this one, we don't use it. The reason is, for example, we have configured, let us say, some 4 to 5 VMs on this, and they're all running, okay? And this is my hard disk, physical hard disk on my host. So every VM will have a virtual hard disk. But when I create this hard disk of the VM, right, it basically creates um, a disk file, and we call it as flat.vmdk in VMware. This is a disk file, which means, see, we have to understand on a physical box, we have a hard disk. The data that we have that gets stored on the hard disk. Here, all these virtual machines are tied to this hard disk, physical hard disk. Let us say we are doing it on the local hard disk. The question is, how will my hypervisor know whose data belongs to whom? Because if all the VMs are storing the data on the same hard disk, how are we going to recognize, right, whose data is this, right? If everything goes into the same disk. So what do you think the hypervisor does? Any guesses here? How can we make sure our data is actually um, kept separately, right, from all the other data? Can I, can anyone think of it? Separate storage, different logins, and creates a folder. Very good. There's someone called Syed Ashraf. He's given the answer. So what it basically does is very simple. On the hard disk, right, on the data store, of course. Let's say this is my data store, which is nothing but a drive on the hypervisor. If this is virtual machine number 1, all the data that belongs to VM1 goes into a folder. It creates a folder. That folder is called as VM1, let us say, and all the data belongs to that VM1 goes into that folder. So it creates folders for each files, each virtual machine. Now within that folder, now obviously the data, it doesn't store the data like how it stores in Windows. Remember, inside the VM, I have C drive and I have D drive. I have my files and folders inside the VM. But the same data, when it obviously stored on the disk here, it is not stored in the same format like files and folders. Just like on a physical machine, my data inside this box, when I log in, it shows up in form of files and folders. But if you access your hard disk, right? I'm not talking about a USB hard disk. I'm talking about your SATA or SCSI disk, right? All you get to see is blocks, right? Sectors. So your data is stored in the form of sectors on the hard disk, but the same hard disk, when presented to an operating system in a partitioned form, then it shows up in file form of files and folders. Here also, virtual machines which hold the data, when it actually gets stored on the data store, they get stored in the form of blocks. When you log in here, you will not see that all your notepad, your MS Word files, you cannot see that. So here, what my hypervisor does, it creates a disk file. That file is called as flat.vmdk. And that single disk will consist of all the data blocks. That disk file is like your hard disk. I can copy that file, put it onto some other data store, and I can map a new VM to that and I can power it on. It's like you can unplug the hard disk from a physical box and plug it to another physical box and power it on, you get to see that. So your virtual machine disk file, which is flat.vmdk, is the hard disk of your virtual machine, right? Let me show you. So when I'm in the lab, if I browse my data store, you see DC01 is my virtual machine. Demo is my virtual machine, which we just created. Hyper-V, all these are my virtual machines. If I look at my demo VM, which I just created, you get to see all these files, right? So the most important one is the one that says, so actually we have not completed the operating system installation. That's why. Here is the one. It's a 0 because we have not installed anything on it. Let me show you some other one. Maybe this one. Flat.vmdk would appear like virtual machine name.vmdk, right? 17.61 GB. This single file this is the hard disk of the virtual machine. All the data goes here. So this file is actually stored on your hard disk of the physical box. Like that, all these separate folders are created, and inside those folders, respective hard disks are created. Now, another thing is, can I have multiple hard disks on a VM? Let me see, some questions have come up. Can we have shared drive that can be used for two VM copies data from one VM to another? I'm coming to show storage in some time, so Sami, just hold on, right? Okay. Now I can have multiple disks to the same VM. Okay, for example, this demo VM is here, right? If I want, I can add more hard disk to this. For example, I go to edit, I get to see this hard disk here, right? I can add another one if I want. For example, here is a hard disk, new one, and the new hard disk is added here, new hard disk. You see this? And I can say some provisioning, whatever. I've got two hard disks. Like that, I can add multiple hard disks to the same VM. Remember, now there will be each flat.vmdk created for a disk. So every disk is associated with one flat.vmdk. If you've got 10 disks on a VM, you'll have 10 flat.vmdks. Hope that is clear, right? It's just like your hard disk. So data goes into the flat.vmdk. Now let's come to our whiteboard, how it is set up in real time. Let's have a look at that. And so now let us say we have got these virtual machines created. All of them, we have installed the Windows operating system on them, and the machine is running fine. Now I will ask a question to you guys. Let us say these all VMs are running fine, okay? Suddenly, this ESXi server, the physical ESXi box, okay? Someone power it off. What will happen to all these virtual machines? Will they continue to run, or will there be an impact? Or will there be no impact? What will happen to the VMs? Will they run, or will they get shut down? All the VMs will go down, right? Very good, fantastic. I'm getting all this one from the chat. Fantastic. Okay, very good, very good. Okay. All right. Which means we are risking all these VMs on this physical box. That's a major risk. If my host goes down, all the VMs will also go down, right? Let us say the host has gone down. Now I have the only option I will have at this point is I have to troubleshoot, fix it, then I will have to bring all these machines up. That's the problem. That is why in real time, we don't set up these machines like this. Let me show you how we set it up in real time. In real time, we're going to use physical box. We don't just use one single box. At least we use two boxes. Okay. Let's say ESXi1, ESXi2. And this machine will have its RAM, CPU, the card. But there is no hard disk. Hard disk will not use. Okay, guys, it's Azan time here. Just wait for 2 minutes, please. Okay, so we've got two ESXi servers. So they have their own hardware. So we bought it. But what I'm trying to say here is on top of that, when I buy these two physical boxes, we are also going to buy centralized storage system. Storage. Right? It's going to be a shared storage, which means this storage box is going to be connected to this host and also this host. And on this host storage, we create partition. For example, we are creating a LUN. Now on the storage box again, the terminology is used differently, not to be confused. In Windows, we call it as a drive. On ESXi host, we call it on a data store. On a storage box, we call it as a LUN. But end of the day, they are just like your Windows drives, okay? So let's say I've got this 1000 GB storage, okay? I can create it LUNs here, and like 10, 100 GB each if I want, right? I can name them as LUN number 1 and LUN number 2 and so on. Now, the good part about a storage box is the same LUN can be mapped to multiple servers. That's a good part about it, right? All right. I think now you're able to see the chats of everyone. One second. You should be able to see. Okay. All right, just hold on. Just a second. So this LUN, I can now, when I'm creating my data store, instead of using this one, I'm going to use this one. All right. So when I create a VM, say VM number 1, that VM is going to be stored here, folder, right? Inside this, I will have my flat.vmdk. This flat.vmdk is physically stored here in the form of blocks. What is the benefit I get with this? Because I can map the LUN1 also here. Now, if this host goes down, this virtual machine, because the hard disk of this VM is available here, and it is mapped on the other host also. I can power on the same VM, right, on this host because it has got access to the hard disk. Because the disk is centrally available, if one host goes down, if the VMs of that host, instead of you troubleshooting and waiting for this host to come up, the other host can bring up these VMs. We'll talk about that high availability cluster and all that tomorrow. Today, just try and understand the reason why we're using this shared storage. The benefit is we will not have a single point of failure anymore. If the host goes down, we will still have options to access the disk files of those VMs from some other host and we can bring them up. That's a reason why we use a shared storage. So we can do a lot of automations like migration of this VM, live migration from one host to another host. For example, if I want to move VMs in Hyderabad to VMs in Bangalore, I can do that. Or maybe from VM1 to VM2, I can migrate them online because both are accessing it, right? Just the registration needs to be changed. The memory content has to be shared. We'll talk about that vMotion tomorrow. But shared storage has a lot of benefits. Hope this is clear. Is this clear, guys, so far? Want you to raise your hands. Not everyone is raising hands. I don't know why. Very good, very good, very good. So now you can send messages to everyone, okay? So everyone can see your messages instead of sending me directly. Someone had concerns that you can't see the messages in the chat. Now you guys can see that because I've enabled the option to see the messages by everyone. Okay, very good. Thank you. Thank you. All right. Don't ask me two basic questions that you can find out online, guys. Okay, don't ask me like, what is the full form of LUN? Because you can put it online and see what's the full form of that, right? You don't need to ask me for that. So ask me something which you have not understood in terms of explanation, right? Something that you cannot understand by reading it, right? There's a question in the chat. Let me see. As VM admin, if a requirement come to us for X, have a server for. Again, honey, if your question, if you get a requirement within your organization for 64 GB RAM, 500 GB hard disk, you have to create a VM with the same configuration. That's a decision of your organization. Now, what I said 4:1 ratio is a decision of an architect. When I am setting up your company's data center, then I'm going to propose it to your CTO, right? I'm going to tell them when you're buying the hardware, only this much you have to buy. But after that is done, within your organization, if you get a request to create a VM with certain hardware, create the VM with that same requirement, right? You can't decide on the ratios. Only architects do that. Okay. So that's about shared storage, right? Then we'll have to move on now and talk about a couple of more things. Just give me a second. Now, when we are connecting these storage, right, shared storage, we get different types of connections, right? So in the real world, there are connections like you can use the network connection. So what I'm talking about is, let's say I have this hypervisor. I have this hypervisor. I got this storage box. When I'm connecting this storage box, so there'll be a switch, right? This host is connected to this switch. This host is connected to this. This storage is connected to this switch. Now, what will be the speed of this? Because remember, my VM is here, but the hard disk of this VM is actually here, which means every time I open a file, the file is not locally stored. It is stored on an external storage. So if that storage is slower, right, it is going to take time, right? So this speed matters a lot. How you're connecting your external storage to your physical environment, your hypervisor matters a lot. So in the real world, we have three types of connections. One is network connection, that is your standard Ethernet. The other one is you have SAN, right? Storage area network. Then we call it as fiber channel SAN or FC SAN. The third one is iSCSI. These are the three types of connections we majorly use in order to get the speed, right? Now, if I want to use Ethernet connection, we all know that I need an Ethernet switch and I need the NIC card here. I need a NIC card here. I need a Ethernet port here, right? On this storage. But when it comes to SAN, right? For SAN, I would require something else. This will not work. For SAN, first thing is it has to be a SAN switch. Second thing, the physical host, it doesn't connect to the Ethernet, it doesn't connect to NIC card. It needs an HBA adapter. Just like how you buy a NIC network interface card on your physical box, you need to buy HBA adapter on your ESXi box. But remember, your ESXi server that you're purchasing, the hardware, has to have that slot on the motherboard. Like on motherboard, you put that Ethernet on the slot, right? So if you're buying a motherboard which doesn't have an HBA slot on that, then you cannot use SAN in that. So you have, that means it's a costly hardware. Likewise, on the other one also, sorry, it needs to have HBA adapter. Your SAN switch obviously will have the required port, FC port, but your storage also requires that FC port on that, which means your storage would be a costly box because it has got FC port. Your physical server also would be a costlier one compared to the Ethernet servers, right? So HBA adapter comes for a cost. So overall, it's a costly affair. But this gives you high speed, right? So speed starts with gigabytes, right? Unlike Ethernet network. So gives you high, if you're really looking for high speed access, then you have to go with this SAN setup, fiber channel SAN. The other one is iSCSI. In iSCSI, basically, you don't require all this. You don't require SAN switch. You can use your existing Ethernet environment. So switch is again, it can be your Ethernet switch. All I need is on this ESXi host, there has to be iSCSI initiator. So it's basically software based, okay? So there must be a software installed on this. So every hypervisor now comes with the uh, iSCSI initiator. It's already there, so you don't need to install anything. But your storage box needs to have iSCSI target installed on it. Again, software. So you buy a storage which has got iSCSI installed on it. You need to check the configuration before buying that storage. If you have this iSCSI target and iSCSI initiator, then you just need to configure them, and then it will use existing Ethernet infrastructure, but still gives you a dedicated speed, which means It's going to be faster than your Ethernet, but not as fast as your SAN, but still gets a better speed. So these are the three types of connections we use in the real-time environment. Clear so far? So Rizwan has questioned how shared storage gets mapped with both hosts. Yeah, you need to connect them, right? Physically, either using any one of these connections, and then inside the host, you have to configure them. There is a way to configure. Okay, very good. That's good. Okay. I think it's more than an hour. So let's do one thing. It's oh my God. What's the time in India now? Need to check that. 9:40, 9:50, right? We'll meet in 15 minutes from now, okay? So you have to be back by 10:05. It's 9:50 now, 15 minutes break, okay? We'll be back at 10:05 sharp. Hold on. Hi guys, hope you're back from the break. Kindly raise your hands if you're back or message me on the chat. Okay, let's see. All right. Okay. All right. So let's, sorry. All right, let's go on. So we are basically in the middle of designing or setting up a host, right? So let's go. All right. So far, it is now clear that how do you set up the storage on it, right? Either you use the local storage or you use a shared storage. If you're using shared storage, there are benefits for you, right? The benefits are, as I said, if your VM goes down, if your host goes down, you have an option that can be powered on, right? We have three types of connections that we talked about: network Ethernet connection, SAN, and iSCSI. Remember, this is not something that is set up by a VMware administrator. These things are done by storage administrators. You just need to know. You don't have to really get into too much of details of SAN and iSCSI, right? But you just need to know how to configure on the host. But otherwise, well, all these concepts about zoning and so on, VMware administrators don't do that. It's a storage admin who takes care of that. Okay, so we have set up the host. Now we'll move on to the networking part of it. Now let's think about it in physical form. If I'm setting up physical boxes, so far what we have learned is how do we assemble a machine, right? A virtual machine. How do you configure a virtual machine, or how do you assemble a physical machine? Just like so. So far, let's say we are clear about the configuration with the CPU, RAM, the hard disk, right? And all this. Let's imagine these are physical machines. In the virtual environment, right? If I was using these same machines in the form of VMs, I would have them something like this. Now, let us say we have deployed the operating systems on all these physical boxes. We do the same thing on virtual machines also. And we have all the required RAM, CPU, hard disk, right? Available here. You have assigned to each of these machines. So when you power on, these machines will turn on. The same thing happens for the VMs also. If I power on, these machines will come up. Because they're getting what they want, right? They need RAM, they need CPU, they need hard disk space, and we have all that available. We have installed the operating system. The machines are on now. The next thing is, what about the networking? If it is physical environment, I would buy a physical switch, right? And then I would obviously have some ports on the physical switch. And all these machines, I'll connect them with a cable, right? But when it comes to VMs, how would I connect these machines? So who can tell me this? How can they talk to each other? These VMs need to communicate with each other. They need a switch, right? Very good. Someone said virtual switch, right? So a couple of people have answered this. We need a switch, obviously, but because these are virtual machines, we need a virtual switch. In VMware, we call it as, we have two types of switches, standard and distributed. We are just talking about a standard. So virtual switch. Don't be confused when I say virtual switch. Now, how would you imagine, right? You know, physical switch you have seen. It has ports to them, and there is connectivity, and we can obviously touch and feel these. But when it comes to virtual machines, because these are virtual, people who are new to this might get confused. But understand, don't worry about the physical connections at all. All we need is we need to have the required, um, I would say, required piece of code, I would say, right? Required piece of code. Hardware is nothing. Hardware is just basically acting on the instructions of a software, right? So everywhere you go, right? For example, you go to a petrol bunk and you see a physical box there, right? But see, remember, they have that button that they press for how many liters of petrol you want. But remember, when he presses that button, there is a program written behind it which makes sure only that much amount of petrol is actually out of that, right? So there is some certain amount of program written behind it. Even in your physical NIC card, right? Network interface card, you can touch and feel this physical NIC card, but I'm telling you, this physical NIC card is nothing. There is a program embedded inside this NIC card, and that program is required, right? So what does the NIC card do? Can anyone tell me what does a network interface card does? What does it do? Or maybe what does a modem do? Communicate. You might have learned this in your school, right? The major function is, um, right. Understand one thing, right? It has the data which is sitting on your physical box, right? And the data that travels through your Ethernet card. These are different, right? Think of it like a modem. When you use modems for your internet access, right? What would the modems do? Modulation and demodulation. They convert the digital signals into analog signals, right? So your physical box has digital signals, but the data that travels over the cable travels in analog signals. It has to convert that from digital form to analog form. Similarly, these network interface cards, right? They have a MAC address, they have a physical address, sorry, they have an IP address. We'll not get into those details, but IP address we use for identification, MAC address we use for communication, right? So they understand their language. They have their language of talking to each other, recognizing their devices, and so on. So this NIC card has a program written inside it, and that program is doing all the job. The same program we have embedded inside my hypervisor, and we are now calling it as a virtual switch. Now, each virtual switch, we can have ports here. Port is nothing but it is more like your network port. And the same program which NIC cards have, that program is available here for you. Another example I can give you is think of it like a physical letter, a handwritten letter, right? Or think of it like an email. What difference does it make if the information is in an email or it is written on a paper? End of the day, I want information. I don't care whether it's written on a paper or whether it's written in the email. End of the day, I've got what I want, right? Same way, same way for my machines to communicate, they need some program, right? Which can help me talk to each other or which can help me transmit the packets, right? Or transmit my bits to the next level, right? From NIC card to, so there is a series that it follows. We call it the ISO, OSI layers, right? So that program is already written. And what we do, these virtual machines are going to be connected to that port. As soon as they are connected, the switch is there. These VMs now can talk to each other. Now remember, if I have got 1000 physical machines, I would end up buying so many physical switches, right? Let's say I'm buying a 48 port switch. I would have to buy like almost 20 switches to get 1000 machines running, right? So if I'm maybe buying 128 port switch, still I would need at least 8 switches, which can uh, help me talk these machines each other. Now you don't require that physical switch anymore. Your virtual switch can help your VMs to talk to each other. So your problem of having physical, yeah, of course you still need physical switches, right? Because if I have got another ESXi server, if these two machines want to talk to each other, I need a switch still, right? Still, I can create VLANs inside these physical switches and make sure these VMs are part of those VLANs and all that. So, but that is not something we can discuss now. But understand for these VMs, a major amount of problems have been solved because of virtual switches. Now, these virtual switches also have virtual ports, sorry, port groups. For example, let us say I've got few production VMs and few are like testing VMs, right? I want to set some restrictions on these machines at the switch level. Maybe I would say these VMs should not be able to communicate to outside machines. Let's say there's another box here and they are backed by a switch. So if I want to set some security policies that really can help me uh, set up. So let's say I've got a switch inside the VM, right? Let's say call it as V switch. These machines are connected to the same switch. Let us say I'm creating a security policy, right? Which which is going to stop all outbound communication. The problem is if I do it at the switch level, all the VMs which are part of this switch will not be able to talk outside. They cannot talk to the VMs which are on this host, for example. But what I'm trying to say here is I want to set these restrictions only to a set of VMs, not all the VMs. Can I do that? The answer is yes. How can I do it? I can create something called port group on my virtual switch. So these ports can be part of a group. And I can set the security policy only to that group. So all outbound communication is blocked for the VMs which are part of this port group. So now whatever restrictions you want to set, you can set it on this. This can be part of another port group. I can set different security policies. So we use port groups in VMware to set our own security policies to the virtual machines. Let me show you in the lab. Okay, here we go. Are you guys able to see the lab? Okay. Thank you. I'm just trying to log in. Just hold on. What happened to this? Generally, it's not slow. I don't know why. Today it's a bit slow. I'm logging into the lab. Riyaz is saying restart. Oh, I can't do that because it's a very big lab. So restart will take a very, very long time. I think I should close the browser and reopen it at least. That will help. Okay. Maybe my internet is slow here. Okay, very good. So I'm logged into this ESXi server. I will show you how to create a switch, right? So if on the left side, you see navigation here, navigator, you see this networking icon. We get to see some switches already here. It just talks about V switch 0. This is also, it's the same switch, which means this is a different one, right? So these are nothing but these are port groups which are part of it. Let's do one thing. We'll create a new switch. Okay. Add a virtual switch. Let's give it a name as demo V switch. Okay. It has got this MTU 1500 and so on. That's okay. As I said, security policies, for example, there are things like promiscuous mode and so on. But this is at the switch level, right? If I enable this, this gets to all the VMs which are part of the switch. So we'll not do that. We'll create a port group and then, so switch is created now. But there are no VMs connected to this, right? We need an uplink is nothing but you have to connect a physical switch to this, right? But I don't think we have an uplink here. So there are no uplinks for us. So anyway, switch is created. On that switch, we can create a port group. Okay. We can say add port group. Say demo port group 1. Okay. Now to which switch, on which switch I want to create this. So I have created demo port switch just now. I'm just going to select. And I have got the security policies here as well. These security policies are inherit from switch means whatever settings are there on the physical switch is going to use that, or I can set my own here if I want. Now my demo switch has got a port group called port group 1. I can add more, right? Let's say demo group 2 and I'll select my demo switch. Now I've got two port groups to my switch, right? Now I can add my VMs to that. For example, I have created a demo VM here, right? I can just go to the settings of that VM and I will see, I'll go to my NIC card and see where is my basically network card connected. So if you see it's by default connected to a switch called production, sorry, port group called production. I will use demo port group 1. Now this VM is connected to my demo port group. Okay. All right. Likewise, I can create more VMs or maybe existing VMs which I have. I can change them. I can let them be connected to my Um, for example, this one. This can be connected to demo port group 2. So when I go to my networking, it tells you on this port group 2, there is one VM connected. This is number of VMs, right? There is another VM connected, right? So whatever policies I create on this group, right? All those policies will get applied to the virtual machine, this VM on this, right? And of course, you can change the security settings from here, whatever settings you want. Is this clear, guys, so far about the switches? Okay. So there's a question, how many ports we have on the virtual switch? So virtual switch, initially, there will not be any ports created. As in when you create VMs, the host will automatically create a port and connect to that, right? So there is, depending on the versions of the ESXi server, you can have like thousands of ports to the switch. So unlike physical machine, you are limited to like 48 switch port, 128. In virtualization, you have got thousands of ports which are supported. You don't have to create a port every time you create a VM. That port automatically gets created. Okay. There's another question, way to put the policy for the group. That's what I showed you, right? When you go to the group, right? This is the port group. If I want to set the policies, I can go to that group. I can say, here are my security policies. I can just say edit settings. Here are the policies. I have security policies. I have NIC teaming policies. I have traffic shaping policies. All these policies I can set on a specific group, right? Okay. All right. That's about the networking part. So what we have done is from the morning today, we have discussed about how do I set up a physical box? How do I um, configure my storage on that? How do I configure my networking on that? And when I create a VM, where are the files going to be stored, right? How do you create a VM? So those are the basic things we have covered so far, right? Now I'm going to show you a couple of things within the virtual machine that when you configure, there are a few things that we need to know, right? First thing is, we all heard about, there's another question. As per our VM, can we add more switches? Yes, you can create more virtual switches, right? You can create, as I just showed you. If I go to virtual switches, I can create multiple virtual switches, and within that switch, I can create multiple port groups. This is all possible, right? But I'll give you Q&A time today in the before end of the session. Like I'll give you some 15 minutes of time. You can ask your questions. I will unmute you. You can speak up and ask me questions. Okay. Now we will move on. We'll talk something about virtual machines. Let us start with something called snapshot. Okay. Now, does anyone know what is a snapshot, guys? You heard about snapshots in VMware? I'm getting all mixed answers here, right? Okay, very good. Someone says screenshot, someone says clone, someone says backup. Okay, stop. I'll ask you another question. In real-time scenario, why do we create a snapshot? I want you to tell me that. What makes you create a snapshot? Disaster recovery, backup recovery, upgrade. Very good, very good, very good. Yeah, good points, guys. Appreciate that. Yeah, stop now, stop. Very good. So, for example, let me give you a scenario, a real-time scenario. Let us say we have a Windows 2016 server, which is running fine in the production. Now, there is a security patch which is released by Microsoft and says you have to apply the security patch. Now I will go ahead and apply that security patch. It will ask me it will ask me for a restart. I will do it. As soon as I restart that 2016 machine, the machine does not boot. It says some files are corrupted. Why is it saying that? It could be possible that the patch that Microsoft released has got some bugs in that. Because of that, your machine got screwed up. Now, the next day, you get an email from Microsoft saying patch recall. They say, we have accidentally sent you the patch. There were some bugs in the patch. We are very sorry about that. We want you to uninstall that patch. The question is, how am I going to uninstall the patch when this has already done the damage to my machine, right? My machine does not boot up now. So I will have to troubleshoot and fix that problem. If not, I will have to restore if I have a backup, right? These are the kind of problems we might encounter. Or at times, I am upgrading an application within that machine, right? For example, I have got SQL installed on my machine. I want to upgrade SQL. You have run the installation, you have upgraded SQL. It has asked you to restart, you've restarted. After machine is up, your SQL does not function now. Why? Because your upgrade was not good, it was not successful. So it, instead of upgrading your SQL, it has actually deleted the existing files in the process of upgradation, and now you have nothing on it. Nothing works for you. These kind of challenges you come across in the real time. So you have to find a way to preserve the existing state of the machine. If anything goes wrong, you should be able to roll back to that previous state. You can do that by backing up the machine, but backup will take time and restore also takes time. I don't want to do that, right? Instead, I want to preserve the current state of my machine, and then I will make sure I do all my upgrade or testing, whatever I want to do, right? And if I'm successful, I will proceed. If I'm not, I'm going to roll back to my previous state. So we have to hold that state. That is what a snapshot does in virtual VMware. Let me give you an example. This is for people who are new, right? Let's say I have a river, right? And I have another river here, and we get the water from this river into this. Maybe this is a lake, okay? This is a river. So you get the water here. Now, your water is filled up in the lake, but you're kind of concerned that at times the river water is infected. And now you want to make sure the river water that comes in does not infect the existing water. What is that you're going to do now? What will you do on this lake to stop infecting the river water? The water will not, you cannot stop the water, it will keep coming. But can I do something here to not to infect my existing water? Change the direction of the river. Okay. All right. Nesting, blockage. Very good. Very good. I've got some good answers now. All I can do is I can create, right, a boundary here. Let the water come, but it does not overflow and does not disturb the existing water. If this water that comes in, if it is okay, then I will break this up. The water will come in. If this is not okay, right, then all this water which has come up, right, I will take this water off. I'll delete this, right? I'll make sure all this water is out of it, and then I'll remove the boundary. So when I create a boundary, only then I will be able to make sure that new thing that is coming onto that lake, that's not damaging my existing water. That's exactly what we do in the virtual machine, right? Let us say now this is my VM. This virtual machine has a hard disk. So the data that we have written is here. Problem is, the need is we are going to add new data, which is going to be written again here. But the question is, we are worried that if we write the same data here, it might be corrupted data, which will corrupt the existing data also. We want to create a boundary here. How can I do that? Well, technically understand now, every hard disk file, every hard disk in VMware is associated with a file. What is that file name, guys? Who will tell me that? I've already discussed that file name. Give me the full name of that file, not just vmdk, flat.vmdk. Very good. Elias has given the answer. Ziauddin, okay, very good, very good, very good. So the file is flat.vmdk. What we're going to do is, we are going to preserve that flat.vmdk. So in the VMware, I will create a snapshot. As soon as I create a snapshot, in the backend, what my hypervisor does is, it creates a new file. That new file name is called as delta.vmdk. All the changes now, the new data is going to go to delta.vmdk. But it doesn't mean that the user, right, who's accessing the VM, he will only be able to access the delta.vmdk. He can access both, but this one becomes read-only for him. He cannot write any data on this old one. Anything that he's writing goes here. So any modification, any creation of new files and folders, they are stored here, which means I'm upgrading. I'm installing some patch. That patch is going to be here, but I can still read my existing data, right? And now after my patch is installation is done, I restart the machine. Now let's say the patch is damaged. It says machine doesn't boot up. I can roll back. I'll show you in the lab. I can roll back to the previous state, then restart the machine. Then it will discard this and it will come from here. As good as we are ignoring that security patch. Let me show you in the lab now. Let's say this is my, all right, here we go. Okay. This is my virtual machine. All I'll do is I'll maybe select this. I'm right clicking. I say snapshot. It says take snapshot. I can give a name, snap one, right? I have two options here, quiet and memory. I'll come to that part, but I'll take a snapshot. I'll take another one just to show you. You can take multiple snapshot, snap two. Now I will go to the snapshot manager and show you that. You see this? Snapshot one, snapshot two, demo, right? So let's say now I'm here. I've installed a patch. I've restarted the machine. Machine does not boot up. All I can do is, instead of waiting for it. Machine doesn't boot up, so I can just right click here on the machine, go to the snapshot manager, and then select the previous state. And I can just say, right, restore snapshot. I'll be restored to the previous state. You see this? Now it says you are here, which means the changes which were done in the snapshot 2, they are going to be there, but we will not be booting the machine from that. We'll boot from snapshot 1, where the changes are good. So this is, I can delete this if I want. So the patch that I've installed will all be discarded. And I'll be back to this snap. So I can jump back and forth. If this is good, I will obviously be here. If this is all good, right? I don't have to keep these snapshots. I can just consolidate them, right? So all I can do is, if I'm here, I can just say delete all, right? If I delete the snapshot, they all get consolidated. They get merged. And if I am here, if I say restore snapshot, and if I delete here, so if I say you are here, anything below you are here, if you delete, that data will be lost. Anything above you are here, if I delete, the data is going to be merged into your flat.vmdk. Remember this. So when you want to discard, make sure you first roll back to the previous state, you come above that snapshot and then delete it. These data changes will be removed completely. If you want to merge it, right, you want to keep, if the changes are good, make sure your here option is always below it. Now you delete it, these changes will not be deleted actually, it will be basically merged into your existing flat.vmdk, which is consolidation. Is this clear, guys? There's a question, will space be taking up on data store when snapshots are taken? Now, when you take an initial snapshot, the snapshot delta.vmdk will be just 5 MB in size. It will not take up much space, but as in when the user starts storing data or making changes to the VM inside the VM, that starts growing, okay, to the delta.vmdk. No snapshots are automatically created. If you're installing a patch, you have to first create a snapshot and then install a patch, okay? Someone asked, can we restore a snapshot if we accidentally delete? No, you cannot. If you have deleted the snapshot, that is gone, right? And there is no way to recover that. You have to be careful about it, okay? Okay, so is this clear? Can you raise your hands and tell me if the snapshot concept is clear? Why we take a snapshot? Now I'm coming to the advanced level of snapshot. Okay, this is basic level. As I said, I will always take you from very basics to the top level. Now we'll talk something which is more advanced. So very few people know about what I'm going to talk now. Okay, let's do that. And I promise you, I'm going to explain you in such a simple way that you will definitely understand that. Let's do that. Okay. Um, when I'm taking a snapshot, I've got these two options here. One is snapshot the virtual machine's memory. The other one is quiesce the guest file system. It says needs VMware tools. That's okay. Does anyone know what this means? Quiescing the guest file system? Anyone knows about it? Why do we do it? No one knows that? Okay. Yeah. So it's very few people know this quiesce guest file system indexing. If you're able to answer this in the interview, I'm pretty sure you'll be hired. Okay, because very few people know this. Let me explain you what is this. And this is actually very important. People don't know this, but it's very important, especially when you're taking a snapshot. I'll tell you why. Now we all know we are taking snapshots, correct? Now, snapshot is more like this. For example, let me give you an example. Let's say there's a person who's continuously running. It's very high speed, never stops. I want to click photo of this guy, picture, right? How can I do, how can I click a clear picture of this guy who is just running always? What's the best way? Who can tell me? Tell me a best way. Sports camera, the memory will be taken along. Now my question is how to take the photo. High lens camera, do continual snaps, taking multiple pics. So I have got only one chance, okay? One click. And I need to make sure that photo is neat and clean. Multiple photos are not allowed. One click, that's it. Because I'm taking snapshot, just I click only once, right? I don't keep clicking snapshots. Very good. Few people are giving. Venu, very good, Venu. Venu has given an answer. Hanif has also given it. They have directly given the answer to me. Okay. Very good. Very good. Two people have, um, right. Let me see. All right. So someone says need to run towards him. So it's very funny. Okay. Best way is to pause this guy, right? Because I want to click a neat photo and this guy is like always running. So there is no way that I can click a photo of this guy. The only option is I need to stop him. Maybe I say pause. Then I click. I can guarantee the clarity of this picture. If I don't do that and I click the photo, the clarity is not guaranteed, which means you click the photo and you tell your manager that I've done my job. Photo is clicked. No one is going to check that photo, right? Now there is a need after 1 month, there is a need to get that photo. Now you get into the camera and look at the picture and you realize, oh, it's not clear. Can we click that photo again? No, that person is already dead now. Now the photo that we wanted to click of a person is no more. The person is dead and there is no photo, there is no proof now. So that's exactly what can happen in the real time when it comes to machines which are very busy. There are some type of VMs which are very, very busy. For example, database machines. Database machines are connected to so many front-end applications. For example, your Ola cab that you book, your Uber cab, your Swiggy, or whatever apps that you use on your phone, they are backed by a database on the data center, right? So imagine there are lakhs of users which are connected to that database. These old guys are always, if some or the other guy is using that application and writing some data or accessing some data. Now, this database is just like this person was always running. So when let's say I'm planning to upgrade this database, or if I'm planning to backup through a backup software like Veeam Backup or any other backup software, those software also have to take a snapshot before doing a backup. Now let us say if I do a snapshot without that quiescing option, it's just going to be an abrupt snapshot. Machine is busy, I've taken the snapshot, and now let's say you're applying a patch. You have taken a snapshot without checking the option, without checking this option. Let's say this one. You don't know what is this setting, so you did not check it. You have taken the snapshot and you have applied the patch. After applying the patch, your patch has damaged the machine. So you're very happy now. Oh, though it damaged, I have a snapshot. I can always roll back. Now you go to the snapshot manager and you select the previous snapshot, you say restore snapshot, you go to the previous state. But when you boot the machine in that state, your machine will start malfunctioning. It will say, it might say anything. It says services do not start, dirty shutdown, can be anything. Why? Because you have taken a snapshot in an abrupt state. The snapshot is not clear. Because the machine was busy, you've taken a snapshot. Just think of it like I'm doing a transaction and half of the information is written, half is still pending, a snapshot was taken, which means this transaction is a failed one for me. I'm doing a Google Pay and a transaction was going on. Some of the information is written, some is not, right? And it takes a snapshot. What happens to this transaction, right? Eventually, this transaction is not recorded in my database. It's a completely failed transaction. Like that, this, because it took it in such a state, the database itself will will obviously be confused because it just doesn't know what to do. So it says like my records are corrupted, I just don't know what to do. My services were busy, you have abruptly stopped me or taken this snapshot, so obviously this will malfunction. This is very, very dangerous. Why? Because your patch that you deploy, the patch might screw up the machine. And when you roll back to previous state, even that is screwed up. There's nothing available with you now. Unless you have a backup, then you can restore from that. Otherwise, you will lose the entire machine. Imagine you losing a database. Imagine a situation where you go to a shopping mall and the mall says, we don't have any information about what you purchased. You went to exchange some item and they say, we don't have any record of this, right? Your customer will lose faith in you. They say, we're not going to buy any items from this guy because they've given me a genuine bill, but there is no information available on the records about this bill. Think of a bank, though banks do take backups, but I'm telling you, in case if that was not done, right, you've deposited some cash and there's no information available now. They say, we don't know how much you deposited, right? Think of a situation like this. So it's very risky. That's why we take a quiesced snapshot. So when I do quiesce, right? Quiescing is nothing but it's simply means freezing. Freeze means stop. That's what I said. We have to pause this guy. So this virtual machine is going to be frozen for some time. How does it freeze the machine? Well, if it is a Windows machine, it uses VSS writers inside the VM. So our VMware tools is going to communicate with the writers. All these writers will freeze the entire machine. So all the write activities will go for a halt. Once the machine is paused, a snapshot is taken. As soon as snapshot is taken, the pause is released. So at this time, there is a business impact we need to remember. Business impact means what will be the impact? It's not like a downtime. For example, at times you might have noticed you're doing a Google Pay, right? It takes some time, right? At times it just says like processing, 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 and then it processes, right? Or at times it times out also. It is just that in the back end, the database is quiet. That's why it is not allowing any transaction to be completed. It's holding in the queue. It says, just hold on. I am kind of in a freeze state now. Not only with Google Pay, like any other applications you might have noticed. At times, not always. At times it happens that they take some time. This is rolling and rolling and rolling, and that just shoots up. Or at times fails. So anything can happen with the end user. Transaction might get failed. He has to reattempt, or he has to wait for some time. So there is a delay. That's a minimal impact, not a major impact. Obviously, it doesn't happen always, right? So maybe once in a day. But the quiescing can really save your life because your database is getting saved. So all the machines which are um, high at write activities, right? on such machines, you have to make sure you put that quiet option and take a snapshot. Remember this. This one must be checked for all the machines which are busy in terms of write activities. Now, don't do it for all the machines. It takes time, okay? When I say busy, don't consider machines which are busy in terms of read activities. For example, there's a web server. On the website, people are accessing, that is also busy. But no one is writing the data on the website. They're only reading it. We don't need it for website. We need it for such machines where data is written continuously, like databases, SQL, Oracle, right? Exchange server. All these machines we need quiescing. Is this clear, guys? Yeah, usually we do a snapshot of the databases during non-business hours, but there are some businesses which are always busy, 24/7. So in such case, there is always some impact, okay? But at times you will have to do it during production hours also. There is a very critical patch that you immediately have to deploy. Then what will you do? You have to take a snapshot, right? And then do it during the business hours. So that there are chances. Okay, very good. All right. So we'll stop here, okay, today. I will give you the lab access as well. The same lab link, I'll give it to you. From the same site, you have to do this lab today, okay? But I'll keep it open for Q&As also. Okay, this is the lab you have to do. I have given you the link yesterday already. I'll give you again. Just practice few of the labs like vSphere and so on. Okay. Hold on. Okay. All right. Few things we'll discuss tomorrow. If you have questions, you can raise your hand. I will let you unmute and then we can discuss on that. So few minutes I'll give you for Q&A. Okay. Second. Just a second. Okay. So questions, people can raise their hand. Let's see who's raised their hand. Where is that? Okay. You can unmute now, Riaz.
Very good evening, sir. Thanks for this wonderful session.
Okay. Please ask
Sir,
your question.
so my background is into Azure Administrator. So I would like to ask that is there any requirement or is there any mandatory, like if I go with the virtualization certification? I have already did the some Azure certifications.
Okay. Now, if you're into Azure, then you don't need to actually go for VMware certification. Knowledge is important, but certification is not important. You can go for Azure certification. That will be more important,
Because
but not
nowadays
VMware.
I am in the like attending the interviews, they are asking the candidates would be preferred if so and so certification will
Correct.
be added advantages.
Yeah, but you're, as you said, you are in Azure stream, then they will not ask you for VMware certification. They will probably ask you for Azure certification rather than VMware certification. All right.
Thank you so much.
Welcome. Okay, next is Mohammed Yunus, right? You can ask. Yunus, I can't hear you.
Am I audible now?
Yes, you are.
Oh, thank you. Well, I just want to ask a question which might be a normal question, but again, I just want to have an answer. What is the difference between that vSphere client and the ESXi GUI, what we use?
Okay, very good question. See, vSphere client is just a tool in order to connect to the ESXi host, right? Just an application, like a console, like Outlook, right? You if you want to access your emails, you use either Outlook or you use Gmail, you log into the browser, you log into the Gmail. So these are just the utilities which help us to connect to the Exchange server in the backend, which can these can pull up the emails and show us. vSphere client is just like that. It can connect to the ESXi server and give us the access. This is just a client. Okay, thank you, Yunus. Next is Abdul.
Hello, sir.